Welcome back. Again, second video for Monday, August 24th's lesson while I'm out for my son's first day of kindergarten. So we're continuing our talk on sets. Last time we had subsets. Today, this section, we're going to be looking at Venn diagrams and some set operations. It's just more of a visual way to see what we're talking about with these sets. A lot of objectives listed here. So a lot of different little topics as we go. Let's quickly read through them. So our first objective, we need to understand the meaning of the universal set. We want to, number 2, understand the basic ideas of the Venn diagram. I think hopefully you guys have seen those enough over the years that you're pretty comfortable with Venn diagram. 3, we want to be able to use a Venn diagram to visualize relationships between two sets. 4, we want to find the complement of a set. That's one of the keys to today, one of the most important parts of it. It's kind of 4, 5, and 6 here. That's kind of the big items for this. And number 5, we want to find the intersection of two sets. And then we're going to find what's called the union of two sets. I will hopefully help make some sense of those two words there later. Perform operations with sets. That'll just be like adding sets together, combining them. Determine sets involving set operations from Venn diagram, and then understand the meaning of and or. And guess what? These words go along with these two things I mentioned up here, the intersection and the union. And then we want to use the formula for the number of elements that are in a combination of things here. So that'll be the last part when we get there. Okay, hopefully the screen works there. Thank you. So I don't know why it goes blank sometimes, but I'm trying not to have to restart things. Okay, so universal sets and Venn diagrams. A little history first. So we have the universal set. Universal set is a general set that contains all elements under discussion. So then, history part of it, John Venn, and it tells you the years that he lived, created Venn diagrams to show the visual relationship among sets. Again, you guys hopefully have seen plenty of Venn diagrams over the years in school. English classes use them. You'll see them all over the place. Now a little bit more with math. Alright, so universal sets are represented by a rectangle. Our subsets within the universal set are depicted by circles, sometimes ovals or other shapes. So essentially it's just talking about, here's a picture. The rectangle kind of represents everything, and then a specific set inside it is this circle portion. And then I also want you to notice, if we're calling this set A, we have this part on the outside with that A with apostrophe after it, kind of getting ahead of ourselves. That is what's called the complement. And essentially, if you have stuff that's inside of A, the complement is basically meaning what's not in A. So it's all the stuff on the outside of the circle. We'll talk about it more when we get there. First example, actually before I do that, I want to remind you, if I'm going fast, please stop and rewind. I'm going to try to go quickly because the longer these videos are, the harder they are to upload. So I want to try to kind of get through this fast because there's a lot more to this one than the previous section. And that was already 18 minutes on the last one. Alright, example 1. Determining sets from a Venn diagram. Use the Venn diagram to determine each of the following sets. So here's our picture. U is everything. So in the universal set, what do we have? I'm sorry, my brace there for my set looks kind of bad, but we'll deal with it. Okay, inside of A, ignore the U and the A. That's the names for the specific set. So U, the universal set, A, this set. So we don't talk about those, but what's inside of A? We have a square and a rectangle. So there we go. There's a square, then I said a rectangle, triangle. Good thing I'm teaching geometry this year. I can remember my shapes better now. And then on the outside here, we have a $sign, an M, and a 5. So in our universal set, there's everything that's in the big rectangle, which are those 5 items. Okay, and then within just specifically set A, we have our square and our triangle. Okay, in C, we want to know the set of elements that are in the universal set but not in A. So essentially, what can we see that I didn't just cover up? the $, the M, and the 5. So, in the universal set, but not in A. Again, we'll see this notation later, but essentially that's the A with apostrophe. Some people, like Mr. Wydick, who also teaches class, will just say A prime. That's kind of a math term. I'll stick to like what's not in A, say A naught, or the complement of A. So the complement of A, what's not in A, $, M5. $, M, and a 5. Okay, representing two sets in a Venn diagram. So there's many ways that we can show two sets, and it just depends on what we're talking about with our sets to how that looks. So first, if they have nothing in common, that's that example. There's no overlap. That means there's nothing in common. Second one, you can't really tell because they're exactly the same. A equals B. So if they're exactly the same set, then you'd really only see one circle because they're kind of overlapping each other, and everything's in the one circle because both sets are the same. Alright, then we get to the next one, to where all of the elements in set A are elements of set B. So A is a subset of B essentially, but that circle would have to be inside, hopefully you can see my little cursor moving there, inside of set B. And then the common Venn diagram that you're used to seeing is where there's some stuff that they have in common, but not everything is in common. And that would look like this one. So we have some stuff that's just in A, over in here, some stuff that's just in B, and then the stuff that they have in common that's in both. Okay, example 2. Determining sets from Venn diagram. We want to use our Venn diagram here, that one, and talk about what's here. I mentioned last class that technically there is no correct order to things, but it is so much easier on me when I'm grading and checking things if we do things the same way, and therefore I'm asking you guys if we have numbers or letters, put them in numerical or alphabetical order, please. It just helps me and makes it a lot simpler. Okay, so if we look at this set, we want the universal set. So it has A, B, C, D, E, F, and G. So all of that stuff's there. A couple more quick comments. The U, A, and B are just noting the different parts of the sets. So the universal set, sorry it went blank. Hopefully I can quickly fix that problem, because I don't want to restart our video. There we go. Not too bad. And losing my train of thought there. Okay, so we had A, B, and U, universal set, set A, set B. The Roman numerals, they're not elements in the set, they're just labeling the different regions, so ignore that those are there. There will be times when we talk about the region and what Roman numeral it is, but for now, just kind of ignore them. So if we look at the elements, we had A, B, C, and then D, E, F, G. So there's our universal set. Okay, then it asks for what's in set B. Set B is all of this. So we have D and E. Again, ignore the Roman numerals. D, E. Okay. Next, the set of elements that are in A but not in B. So we want stuff that's inside of A, but not the stuff that's inside of B. And with me scribbling on things, it's easy for me to erase, easier than me using a pencil. But I think it's very helpful as a visual, so you can use your hand to cover up, things like that. It'll help you as you go. Alright, so what's in A but not in B? A, B, and C. The next one, what are the set of elements in the universal set that are not in B? So basically anything else except for what's covered up there. So A, B, C, F, and G. And ignore the clock in the background again. Every 15 minutes. And you'll see how long the video takes if you have to hear it again. Then part E, the set of elements that are in both A and in B. So what's in A and in B? This part right here. So just the letter D. There's only one element that's in both. Alright, so that's kind of the basics about just generic Venn diagram stuff and listing what's in different parts. Now we need to be able to talk about a complement, which I've briefly touched on already. So we have the complement of a set such as A, symbolized by A again with that apostrophe. We can say A naught, we can say A prime, or we can say complement of A, is the set of all elements in the universal set that are not in A. So here's A. The complement of A is all that stuff on the outside, the blue shaded part. The idea can be expressed in set builder notation as follows. So the set of all elements X, such that X is an element of the universal set and X is not an element of A. We don't really need all that technical stuff here for the set builder notation. Okay. Again, it's that shaded region, I already said that. So let's look at it in practice. So this time our universal set has the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, which we see right here. And then in set A specifically is the numbers 1, 3, 4, and 7. We want to find what's not in A. So, hey, what's not in A? Yeah, 2, 5, 6, 8, and 9. So what's not in A? 2, 5, 6, 8, and 9. And hopefully relatively simple so far. And I'm not losing you yet. And hopefully I won't. Okay, next page. Now we're looking at intersection and union. Again, I'm going to have some words to help you remember these a little different. So first thing we have is the intersection. Okay, the intersection of sets A and B, written this way, okay, is the set of the elements that are in common to both set A and set B. Okay? So the key there, and. So guess what intersection means? It means and. So realistically, this symbol right there, that's kind of like an upside down U, that means and. And we need to know that. So a lot of times from now on, if I'm talking about and, I'm just going to use this symbol, which again is kind of just that upside down U. And I'm ignoring the set builder notation stuff. Let's skip to the next one, which is the union. So the way I remember this is the union is the one that looks like the U, and the intersection is the other one, the upside down U. And in this case, we have the union of sets A and B, written as A union B, which again we'll have a word for in a second, is the set of the elements that are in A, or, there's our key, or in both sets, so A or B, or in both sets. So what does this symbol mean? So A union B, that symbol means or. Okay? So when it's the upside down U, and when it's a regular U, or. Okay? Alright, so some extra information here that might help you on a couple of problems later. For any set A, so A and the empty set, what would they have in common? So you have some stuff in A, you have something that's empty. What would they have in common that's in both? Nothing, because one of them has nothing. So that's why it's the empty set there. And then if you're combining things, okay, so I want to add those words in back up here too. With and, you're looking for what they have in common. Okay? So I'm just going to write in common. With or, it's what you get when you combine things. So combine. Okay? So finishing this thought here, maybe. If we have A or the empty set, so if you take whatever's in A and you combine it with nothing, okay, put those two things together, what do you have? Whatever was in A, which is why it's A there. Alright, finding the intersection of two sets. We want to find the following intersections. Okay, so intersections and. Okay, what else did we say up here? This is what they have in common. There we go. Didn't know if it was going to work for a second. Alright, so if we're looking for the intersection, we just look to see what they have in common. So on the left side we have 7, 8, 9, 10, 11, and then we have 6, 8, 10, and 12. So 7, no 7. 8, they both have an 8. 9, nope. 10, they both have a 10. So what is our intersection? What do they have in common? 8 and 10. Well, it's supposed to be a brace, not a 3. And it doesn't want to erase, so I'm just going to write over the top of it. And now it doesn't look like either one, but it's a brace. Okay, for B, what do these two have in common? So we have 1, 3, 5, 7, 9, a bunch of odd numbers, and 2, 4, 6, and 8, even numbers. So is there anything that the odds and evens have in common? No. So we could show that as an empty set of braces. Or we could just simply do our other symbol there. I wasn't sure if that was going to write. And have that. So ignore my little extra little mark there. Just nothing wants to erase tonight, so oh well. Alright, in C, we have a set that has something. Odd numbers, 1, 3, 5, 7, 9. What does that have in common with the empty set? So we have some stuff here. We have nothing here. What do they have in common? Nothing. So it's, again, either empty set that way or that way, whichever way you prefer to write it. You don't need to write both. Just pick one and just know that they do mean the same thing. Alright, practicing some unions. Union, again, you just combine the two together. So just kind of think of taking them and kind of smashing them together, and whatever's there is there. So if we have 7, 8, 9, 10, 11, or, remember that means or, 6, 8, 10, and 12, we just combine those together. If you have repeated numbers or elements of any sort, you don't need to list the repeats. So I have a 6, 7, 8, 9, 10, 11, 12. Again, it's easier to put them in order for me to grade. Please put them in order. And then, again, skip your repeats. So I didn't need to write the 8 twice. I didn't need to write the 10 twice. We just list them one time. So we just combine the two things together. Okay, letter B, same idea. We take all the odds, or our set with the evens, or again means we just combine them together. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then last one, combining with the empty set. So we have 1, 3, 5, 7, 9. We add nothing to it. What do we have? 1, 3, 5, 7, 9. That is it. Okay, set operations. So this is now just kind of taking something that's in the universal set and finding combinations of things. So our first example here, we want to find what's in A or B, but then we want the complement of it. So basically how would I read that? I would say what is not, the complement means not, what is not in A or B. And I would just do that in steps. Okay? So first thing I would do is find what's in A or B, and then I'd figure out what's not there. So again, it's not the answer, but I'm going to start with finding what's in A or B. Right, so here's my three sets, my universal set. So that's everything total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my two specific sets, A, 1, 3, 7, 9, B, 3, 7, 8, 10. And if I combine those two things together, I have 1, 3, 7, 8, 9, 10. 1, 3, 7, 8, 9, and 10. Okay, now we want to find the complement to that. Okay, so I'm going to erase my box there. So what is not in A or B? So here's what's in A or B up here that we just found. What's missing from the universal set? Well, we have a 1. Oh, we don't have a 2. We have 3. We don't have 4, 5, and 6. And then we have 7, 8, 9, 10. So that's it. So you can ignore my extra comma there. I'd try to erase it, but my eraser hasn't been working on here. Okay, next one. We want what's in the complement of A and also in the complement of B. Okay? And what do they have in common? So my suggestion on problems like these, especially if you have a lot of different parts with just some given sets. So for example, on your homework, you might be given 3 sets like this, universal set, 2 specific sets, there might be 5 questions about them or 8 questions about them. So one of the very first things I would do is list out my complements right next to the other sets so that you can see exactly what you're working with. So if A is 1, 3, 7, and 9, what's not in A? 2, 4, 5, 6, 8, and 10. Okay, then what's not in B? 1, 2, it has a 3, 4, 5, 6, it has 7 and 8, doesn't have a 9. Okay, so those are our 2 complements. Now we want what's not in A and also not in B. So basically, what do these 2 have in common? So maybe I'll use my highlighter if it'll work. They both have a 2, they both have a 4, a 5, a 6, and that's it. So 2, 4, 5, 6. So that's what's not in A, and also what's not in B. So it's what those 2 things have in common, 2, 4, 5, and 6. Continuing. On this next page, I kind of filled in some stuff ahead of time to save me some time for the video. And there's another disclaimer about saving time there. Okay, but we have a universal set, we have sets A and B, and then we have these regions with Roman numerals that I referenced earlier. So 1, 2, 3, and 4. 1, 2, 3, 4. Those regions. So this is just kind of a place for you to reference and come back to when you're maybe struggling on a problem. If you need some extra help, this is just there as a visual to kind of help you see what we're talking about. To save myself a lot of time in writing, basically all of these except for letter E start the same way. So I said to save space, each of these starts with the set of elements in, and then instead of writing that out each time, it was the set of elements in, and whatever. So in this case, we had A or B. So what's in A or B? That would be A or B is all of this. 1, 2, and 3. Okay. What's not in A or B? So what's not there? 4. Okay. I'm going to go through these quickly. Hopefully, if you need them, you can go back, watch the video again, and see what's there. Alright, A and B for C. So, sorry for letter C. What's in A and in B? A and in B is just region 2. Okay, then what is not in A and B? So basically what's not there? 1, 3, and 4. Okay, the words are more confusing to me, I think, than just looking at it visually, so it's very helpful to see the picture there. Okay, and E, what's not in A, but also inside of B? So, not in A are these 2, but it has to be inside of B for that. So what's that then? Just 3. And then last, what's in A or not in B? So inside of A is those 2. Okay. What is not inside of B? 1 and 4. Okay. And be careful because I know I crossed it out. But since it's an or, we're combining them. So if we look at first part first, what's in A? 1 and 2. And then what's not in B? 1 and 4. So if we combine those together, you get your 1, 2, and 4. And I know I went through those kind of quick. Watch the video again if you need to see some of those again. Alright, so our sets in precise use in everyday English. So set operations Venn diagrams provide precise ways of organizing, classifying, and describing the vast array of sets and subsets we encounter every day. So organizing, classifying, and describing. Not so important there, but we're going to fill it in quickly. Okay, we've already talked about these words, but hopefully you remember now that union, that's our or, and that's your U symbol. And then and was our intersection, which is the upside down U. Alright, cardinal number for the union of 2 finite sets. This, I think, is our last part of this. So we have the number of elements that are in A or in B. How do we calculate that? We take all the stuff that's in A, so the number of elements there, add the number of elements that are in B, and then we have to subtract out the stuff that's in A and B. So really quickly, if we come back up here to see why we have to do that. If we take all the stuff that's in A, that's 1 and 2. All the stuff that's in B, that's 2 and 3. And then it says to subtract what's in A and in B. So we're going to subtract a 2. So that plus that minus a 2. Why are we doing that? And I know I went from showing my Roman number one way then to a different. But basically we counted region 2 twice. So then we're just subtracting it back out. Okay? That's why we do that. Hopefully that makes sense when you do it in practice. Yeah, and basically that's our last example here. So we have some of the results for Campus Blood Drive survey indicated 490 students were willing to donate blood, 340 students were willing to help serve a free breakfast to the blood donors, and 120 students were willing to do both. How many students were willing to donate blood or to serve breakfast? I'm going to do two things here. One, I'm just going to go straight to the answer, and then two, show you how you could fill those numbers into the Venn diagram, because a lot of people do that wrong. So first, if we just think what was on the bottom of that previous page, it says we take the stuff in group A plus the stuff in group B, and then subtract what they have in common, 120 that are willing to do both. So you just simply take your 490 plus 340 minus 120 that are doing both, and that should be 710 if my notes from previous years are correct. Okay, really that's it. But I do want to show you this very quickly. How do we fill in those numbers into a Venn diagram? You always want to start in the middle. So if we start in the middle, we have 120 that they have in common. Okay? Where people make mistakes. We have 490 students that are willing to donate blood. If I put in 490 here, look at set A. It doesn't just have 490. Now it has, 610? It has too many people in there. So you have to realize that you've already accounted for 120 of those 490. So that would mean there's 370 there. Together, now we have our 490. And then the same thing for the other set. We have 340, but we've already put 120 of them in this circle because that's what they have in common. So then we just need another 220. Okay? And if we were to add up those three numbers, that should give us our 710. So 490 plus, so 370, 120, 490, plus another 220. That should be our 710. Okay, again, I know things got fast at times. It's a longer video than I wanted in general. So hopefully you can get through that and get to some work. Do as much of the work as you can. Next class, I'm going to spend a lot of time trying to get through 3 sections worth of homework at this point. So don't worry about trying to turn anything in yet. You don't need to email me and ask. You're not doing anything wrong. I haven't put a thing in the gradebook yet, and I won't until I see you guys next time and we talk about these 3 homeworks. So do the best you can on these 2 sections, so the 1.2 and 1.3. I'm going to look at sections 1.1, 1.2, and 1.3 on Thursday with you guys, whether you're in person or doing a Teams meeting to be able to see it. All right, have a good day. Thank you.